This rock formation is one of Saguaro East's favorite photo spots. It's also a cutaway view of how rock got changed along the detachment fault. Scientists have taken a look at the microscopic secrets of this rock, and this is what they found. This single crystal of zircon grew inside the granite over the course of hundreds of millions of years, creating rings of minerals as it grew. It began 1.6 billion years ago, the same time as the sea mud we saw at Javelina Wash. And it put on its last growth 25 million years ago when the detachment fault was active. It's like a calendar of important events in our geologic history. Unless you've brought an electron microscope with you, you're going to have to settle for enjoying the banding in the rock behind me. It's called mylonitic gneiss, or just plain mylonite, and it used to be granite. Granite is an igneous rock, one that's cooled from molten material, and it looks something like this. Notice the cubes and spheres of mineral in this rock. These are the quartz, feldspar, and mica that make up granite. Now, look at the rock above you. How did the minerals get into the long lines that you can see up there? A simple answer is they were stretched. If you've brought along the colored rubber glove, you can think of how this happened. Or you can just look at the one I have here. The shapes drawn on the glove represent the minerals as they originally formed far underground more than 1 billion years ago. During the 10 to 15 million years when the detachment fault was active, the granite was under tremendous pressure and friction. These forces were so great that the rock became hot and elastic, like this glove. Stretch this rubber glove model of granite and you can see how the crystals get stretched. That's what you are seeing in the Javelina rocks. Because it's been changed in shape from what it once was, mylonite is considered a metamorphic rock. If you hike up the ridge, you're going to see mylonite for miles. But the farther you get from the fault, the less change there is in the rocks. The heart of the range is still like granite. That's why the evidence of geology along the drive, from ancient ocean muds to great fractures in the earth, to granite stretched to look like taffy, brings scientists and students from all around the world right here to Saguaro National Park. And that's why this book, called Arizona Rocks, A Guide to Geologic Sites in the Grand Canyon State, has a picture of Javelina rocks on its cover. So get the book and go exploring to other Arizona geology hotspots, including the remains of the volcano now found in the Tucson Mountains. We hope you enjoyed this tour and that we'll be able to see you in person at Saguaro National Park very soon. Explore your park safely and have fun.